Welcome to aminacademy.com. In engineering mechanics, let us discuss about maximum velocity and acceleration of simple harmonic motion. We know that velocity of simple harmonic motion, velocity equal omega into square root of r squared minus y squared. Already we discussed. Here, r is the amplitude here. The velocity is maximum when y equals 0. The velocity is maximum when a particle when a particle position when a particle position y equal 0, or we can say the n passes through O, n n passes through O, that is center of oscillation, center of mean position. Therefore maximum velocity, therefore V maximum velocity equal omega r squared minus 0 squared, which is equal V max equal omega r, because square root of r squared is r only. Let 1 here. It may be noted from the equation 1, look at this equation 1, will show that velocity is maximum and equal 0. Then it may be noted that from equation 1 that its velocity is 0 when y equal to r. Also, velocity is 0 when y is r, y equal, that means that velocity is 0 at this position, that p, suppose p comes here or here, the velocity is y equal to velocity is 0 when y equal to r. Therefore acceleration a equal omega square y, because r equal to y. Therefore maximum acceleration a max equal omega square y, omega square y equal to r, omega square r. Therefore V max equal omega r, a max is omega square r. Now let us do an example. We can understand this concept clearly. A body is moving with hm, performs 12 complete oscillation per minute, and its speed is 60% of the maximum speed when it is at a distance of 8 cm from its center of oscillation. Find amplitude, maximum acceleration of the particle. Also find the speed of the particle when it is 6 cm far from the center of oscillation. Here, the given oscillations per minute equal 12, and displacement that is y equal 8 centimeter. Velocity v equal 60% of v max. Then first we'll do amplitude of the particle first. We'll discuss about the amplitude of the particle. In this, here we know that number of oscillation per second, number of oscillation per second is 12 by 60, because 12 oscillation per minute is 12, so per second is 12 by 60 is 1 over 5. Therefore, time period of oscillation equal t equal 1 over 1 by 5, which is equal 5. That is 5 seconds. Now, angular velocity omega equal 2 pi by t, 2 pi by 5 is 2 pi by 5. We will calculate this. 2 into 3.14 divided by 5 equal 1.256. 1.256 radian per second. Now, linear velocity is v equal omega r squared minus y squared. V equal, but v is 60% of its maximum. That is, v velocity is 60% of its maximum. Therefore, 0.6 v max equal v. That is, 0.6 v max equal omega. Omega is 1.256 square root of r squared minus y. Here displacement y is 8, that is 8 square. Here 0.06 v max equal to omega r equal 1.256 into r squared minus 64. 0.6 into omega is 1.256 r into r equal 1.256 into r squared minus 64. Here, from this we can find r squared minus 64 equals 0.6 into 1.256 r over 1.256. So h cut here r squared minus 64 equal 6r. Squaring both sides, r squared minus 64 equal 36 r squared. Now 0.6 r, not 6 r, 0.6 r, here 0.36 r squared. Therefore, then r squared minus 0.36 r squared equal to 64. That is r squared 1 minus 0.36 equal 64. Then r squared equal 0.64 equal 64. R squared equal 64 over 0.64, which is equal 100. Then r equal square root of 100 equal to 10 centimeter. Next one, maximum acceleration. We got radius is amplitude, that is amplitude 10 centimeter. Next, maximum acceleration of the particle. Maximum acceleration of the particle. We know that A max equal omega r, which is equal, omega is, already we have omega 1.256 into 10 here, that is 12.56 meter per second square. Now speed of the particle. Next, speed of the particle when it is 6 centimeter from the center of oscillation. From the center of oscillation is given as V equal omega square root of r squared y squared. That is V equal omega is 1.256 square root of 10 square minus 6 square, which is equal 1.256 into 100 minus 36 is 64, which is equal 1.256 into 8, which is 1.256 multiplied 8 equal 10.0 10.048 meter per second. We have done. Please subscribe our YouTube channel.